Students, welcome to my channel Common Sense Explore. Today I will explain about how eigenvalues and eigenvectors can be calculated for a 2 cross 2 matrix. First of all, you can see here there is a question: find the eigenvalues and corresponding eigenvector of the matrix A equals to 5 4 1 2. So as you know that this is a 2 cross 2 matrix, so please remember stepwise. Okay, so I will explain you stepwise each and every step. Just keep it in your mind. First of all, there is a characteristic equation you can write in step 1 as the characteristic equation of a matrix is nothing but can be written as the characteristics equation can be written as A minus lambda I. Okay, so A minus lambda I is equals to 0. That means the determinant of A minus lambda I equals to 0. This is the first case. Please remember, this is the first case. A minus lambda I equals to 0, where I is the identity matrix, lambda is called parameter, or you can say the roots of the characteristics equation, or A is the matrix given matrix. Okay, so as it is a 2 cross 2 matrix, you can write the lambda or I matrix as I matrix. You have to write also in 2 cross 2 matrix like I2 matrix is 1 0 0 1. 1 0 0 1 is also a 2 cross 2 matrix, because as A is a 2 cross 2 matrix, you have to take I also 2 cross 2 matrix. Is that clear? So now lambda into I, so write down here lambda into I is nothing but lambda into 1 0 0 1. Okay, so it can be written as lambda 0 0 lambda. Just see here, lambda 0 and 0 lambda is the lambda I value. Is that clear? Now the step 2, A minus lambda I means the subtraction. There is a minus sign means subtraction. You have to do subtraction. So write down in this way, A minus lambda I. A, write down first A. This is A, 5 4 1 2 is A. Okay, minus lambda I. Lambda I is already I have been calculated. That is lambda 0 0 lambda. Write down here lambda 0 0 lambda. Is that clear? So 2 matrix I have written already. Now bracket no need to give the mod value. Mod means nothing but the determinant value. Okay, I have to calculate the determinant and make it 0 to get the value of lambda. Okay, so determinant of this matrix is equals to 0. This is the second step, you can say. So second step, now see, just see the subtraction. So 5 minus lambda can be written as 5 minus lambda in this way. So 4 minus 0 can be written as 4. Okay, 1 minus 0 can be written as 1, and 2 minus lambda can be written as 2 minus lambda. Okay, and mod value will be equals to 0. Is that clear? And mod is nothing but the determinant, as I told you. And in case of determinant, 2 cross 2 determinant, the this elements and this element will be multiplied minus this element into this element. This is the formation. So I am writing here this into this minus this into this. So I am writing in the next line here also, you can say, so 5 minus lambda into 2 minus lambda minus 4 into 1 is 4 equals to 0. Is that clear? Next line is normal multiplication. 5 into 2 10 minus 2 lambda minus 5 lambda plus lambda square, lambda into lambda, lambda square minus 4 equals to 0. Is that clear? And the next line, just rearranging lambda square minus 5 lambda minus 2 lambda can be written as minus 7 lambda, plus 10 minus 4 can be written as plus 6 equals to 0. If you do the middle term factor, you will get two values. One is lambda minus 6, another is lambda minus 1 equals to 0. Okay, so there are two values you can get. Now from this equation you can write lambda equals to either 6 or 1. So these are the roots of this characteristics equation, whereas this is the characteristic equation. As I told you, by this determinant of this equation, you are getting actually this value. Okay, you are getting this value. So this is called characteristic equation, and this is the roots of characteristics equation. Roots, and roots means, as I told you in the previous video, roots means these are the nothing but the eigenvalues. Okay, so you have already calculated eigenvalues. Okay, now you have to calculate the eigenvectors, as I told you, corresponding eigenvector for the eigenvalues. So as they are getting, you are getting two eigenvalues, you will get two eigenvector in this way. So just see the process. So this is how you have to solve the eigen values. Just keep it in your mind each and every step. First step is a minus lambda I mod. Mod means determinant equals to 0. Now a already given and lambda I means you have, as it is 2 cross 2 matrix, you have to take I also 2 cross 2 identity matrix. Now lambda into I means lambda 0 0 lambda. Now I am doing subtraction and doing this equation. By doing equation, by solving it, we are getting these roots 1 and 6. Okay, now the next step, I have to calculate the eigenvectors. Now I am rubbing it, only these two part is important, 1 and 6 is important. Please remember 1 and 6 is important. I am rubbing the rest of the part. Okay, so in the previous video, as I told you already, the eigenvector can be written as, so what is the lambda values? Lambda one is 1, another is 6. Okay, so now as per the eigenvectors formula, eigenvectors for lambda equals to 1, first I will calculate for lambda equals to 1. Okay, how to calculate for lambda equals to 1? Please remember, this is the formula. Formula is a minus lambda I into x equals to 0. Here x is the variable matrix, x1, x2, x3 in this way, either row matrix or column matrix. So how to write? Just see. Please remember each and every step I am doing here. Okay, so a minus lambda I, a, where a lambda equals to 1, for lambda equals to 1 I am solving it. Okay, so a minus lambda 1 is nothing but, what was the calculation? 5 I am doing here, 5 4 1 2, a minus lambda I means lambda is 1, just put it 1 here, 1 0 0 1. Okay, so 5 minus 1 is 4, 4 minus 0 is 4, 1 minus 0 is 1, and 2 minus 1 is 1. Okay, and x can be written as x1 x2 in this way equals to 0. So according to multiplication, 4x1 plus 4x2 equals to 0, or you can write x1 plus x2 equals to 0, because multiplication means row into row plus column in this way, na? So 4x1 plus 4x2 equals to 0. Next step, let x1 equals to 1. Let x1 equals to 1. Always please remember why I am taking 1. Always do in this way. If x1 equals to 1, what is the value of x2? In this way. Okay, so let x1 equals to 1, so x2 will be equals to, from this equation, x2 can be written as 4x2 is equals to minus 4x1 from this equation. 4x1 from this equation, can I write this? Now 4 cancelled, so x2 can be written as minus, this is x1, minus x1. So as x1 is equals to 1, so can I write minus 1? So that means x1 is equals to 1 and x2 is equals to minus 1. So for lambda equals to 1, what is the matrix formation? x1 is nothing but, first you have to write 1 and minus 1 in this way, column wise. This is the vector for eigenvector for lambda equals to 1. So the first part done. And for lambda equals to 6, you have to calculate for lambda equals to 6. Next line, eigenvector for lambda equals to 6 I am solving here. Okay, how to solve? Very simple, very easy actually. So lambda equals to 6 means just put the value lambda equals to 6 means here it will be 6, so it changes into 6, so 6 0 0 6. Okay, now solve it. A minus, similar way, a minus lambda I into x equals to 0. Okay, so a minus lambda I, this is a minus lambda means 6 into I means 6 0 0 6 into x is equals to this. So I am doing directly. Okay, I am doing directly. 5 minus 6 is minus 1, 4 minus 0 is 4, 1 minus 0 is 1, and 2 minus 6 is minus 4 into x means you have to write in this way, x1 x2, just like this equals to 0. So any one equation you can take, either the upper portion or lower portion you can take. Okay, so here I have taken 4x1 plus 4x2 equals to 0. Now I am taking the bottom portion. Okay, you can take upper portion also, no problem, but you can take any portion. So x1, 1 into x1 is x1 minus 4 into x2 equals to 0. Again, let x1 equals to 1. If x1 equals to 1, what is the x2 value? If x1 equals to 1, what is the x2 value? x2 is coming 4x2 equals to x1, so x2 is coming 1 by 4. As this is the problem, whenever x2 is coming 1 by 4, you cannot write fractional way. So what you have to do, just multiply in both sides with 4. Here also 4, here also 4. So it is coming 4 and it is coming 1. So is that clear? That means if x2 equals to 1, x1 equals to 4. So if x2 equals to 1, x1 equals to 4. So what is the second x2 value? You have to write in column wise. Okay, column wise it was the 1 into 1 minus 1, x1, x2 you have to write in this way. x1 is 1 and x2 was minus 1. Here x1 is 4, so write down 4 here, and x2 is 1, write down 1 here. Okay, so that means this is how you have to solve the eigenvector for a corresponding eigenvalues. So for eigenvalue lambda equals to 1, this is the eigenvector. For eigenvalue lambda equals to 6, this is the eigenvector. Now whether you have done correct or not, how to check? This is the backward process, you have to check, okay, whether you have done correct or not. So do correction. First of all, this is the matrix for 5 4 1 2. This is the matrix multiplied with this 1 minus 1, okay, equals to, what is the value of lambda? Lambda is 1 minus 1. Means you have to check left hand side multiplication and right hand side multiplication are correct or not. Okay, so 5 ones are 5 minus 4, so that means 1 is coming. 5 ones are 5 minus 4, that means 5 minus 4 is 1. Done. So 1 ones are 1 minus 2, 1 minus 2 is minus 1. Just see, you can check here. Right side में देखो, 1 into 1 is 1, 1 into minus 1 is minus 1. So left hand side and right hand side are same. That means it is correct. अभी इसमें चेक करो. इसमें कैसे चेक करेगा? देखो 5 4 जो मैट्रिक्स है उसको लिखो पहले. 5 4 1 2 लिखा, 5 4 1 2. अभी क्या लिखना है? ये जो वैल्यू आया है, मतलब आइगन वैल्यू आया है, उसको लिखो. फिर 4 1 लिखो इक्वल्स टू, क्या चेक करना है? राइट साइड में क्या लिखना है? ये लैम्डा इक्वल्स टू 6 लिखो. पहले 6 लिख के ये आइगन वेक्टर लिखो, 4 1 लिखो. ठीक है, तो अभी चेक करो. 5 into 4 is 20. 20 plus 4 into 1 is 4. 20 plus 4 is 24. Okay, 1 into 4 is 4. 2 into 1 is 2. So 4 plus 2 is 6. So left side में क्या आया? 24 and 6. Right side में just check it whether it is coming right side also or not. Okay, so 6 into 4 is 24. 6 into 1 is 6. That means left hand side and right hand side are same. That means whatever the process you have done is absolutely correct. Okay, so this is how you have to solve a 2 cross 2 matrix. Okay.